Good evening, everybody, and greetings from the great garden state of New Jersey in the United States, of course. Welcome to our second meeting of September. We have a real treat for you tonight. We are fortunate to have been on the Foojay OpenJDK 17 plus Java user group tour. So before we get started, let's see, here we go. I will share my screen and just give me 1 second here. There we go. Okay. So the agenda for tonight, as we do every month, we always thank our sponsors for their generous support, for our user group all year long. A couple of what's new items. I'm going to first introduce Geertjan Wielenga, and he's going to talk to you about Foojay IO, and then we'll introduce Simon Ritter, who will actually give our presentation. And at the end, there's an IntelliJ IDEA license giveaway. There is the URL to put your name and your email address, and you need to be present at the end in order to win. Okay, our platinum sponsor is JFrog. Our silver sponsor is Azul, and both Geertjan and Simon are both with Azul, so we thank them for their support. We are partnered with DevNexus. That is an annual conference, usually in the winter time frame, like February, and that's run by the Atlanta Java User Group. Our per meeting sponsors are JetBrains, who donate a license every month for IntelliJ IDEA. And Jakarta EE provides video conferencing via Crowdcast that we have used in the past. So what's new? First and foremost, this has been a long time coming. We have a meetup page, and we already have a couple entries in there, and maybe some of you have already RSVP'd, so we thank you for finding us and doing that if you have done so. The JCon Online Conference is Tuesday through Friday, October 5th through 8th. There's free admission to the Garden State Java User Group members, and there is the URL in order to do that. And as a matter of fact, Simon Ritter, who's our guest speaker, is also speaking at this conference. The Jakarta EE ambassadors put together a Java community acceptance testing, and the original end date was supposed to be October 1st. However, I guess with summertime and everything, there's not been much activity. So today we decided to extend that into the end of the year. So it's, I can show you later on a picture of that and where you can go, but this is the URL to read all about it and then provide feedback on doing any kind of testing on the Jakarta EE specifications. Oops. So with that, without further ado, I'd like to introduce Geertjan Wielenga. He is a senior director of open source project at Azul. He's also one of the partner groups that are part of the Foojay IO. You may have heard of that. Please go there. There is a wealth of information, blog posts. And I think one of the highlights of this is the ability to see from all the different Java classes, for every JDK that's been released since Java 1. And I think that was pretty cool and how you can do that. So with that, I will stop sharing. And we'll bring it over to Geertjan, who will share his screen.
Perfect. Thank you very much. And you should be seeing my screen right now. Right. So hello, everybody. My name is Geertjan. I'm in Amsterdam. And very briefly, in about 2 minutes, I'm going to give you an overview of what Foojay is and what it's all about. So Foojay stands for Friends of OpenJDK. So it's a place for Friends of OpenJDK. And at the moment, what we're doing is a tour through a lot of different JUGs to talk about Java 17, what's new in it and around it, so including topics like Raspberry Pi and JavaFX and so on. And what you find on Foojay is as well something called Foojay Today, which is essentially a blog page, and every day for over half a year now, there's been at least one new article per day. For example, if you search for Chandra right here, you'll find there is a bunch of content by him. So his amazing Apache Maven series is being published on Foojay on a weekly basis. And so you can see very nicely structured and organized is a lot of content on all kinds of different categories connected in one way or another to Java. So every day there is new content to be found on Foojay. Now, what there also is one of the confusing and interesting things about Java, of course, is that there is a quarterly update. And what's interesting is that few, if any, know what is actually in those updates. You assume that there are many great features, enhancements or fixes or performance, etc., etc. But what exactly is in there? So you can see here per quarter, you get a list. In July this year, there was an update to Java 11, and in April and in January. And for each, you can see what the issues were that were fixed. And you can vote on those issues, and you will find then the highlights page shows the fixes with the most votes. So it's basically a community view on what is most popular in that quarter for that release. What you also find on Foojay is quite unique as well, is a list of the different OpenJDK distributions, so the different vendors. Now, understandably, for example, Red Hat has no interest in highlighting the fact that it is one of many different OpenJDK distributions, as is the case for Azure, as is the case for Amazon. So where would you go to actually find a place where all the different OpenJDK vendors are listed with links to the different distributions? And that really is what Foojay is for. It is vendor neutral. It has an advisory board of different organizations. So aside from Azure, Datadog, DataStax, Gluon, Hazelcast, JFrog, Payara, Sneak. So these are all well-known community-orientated Java tech organizations, and this list is growing. One thing we're doing as well, aside from this campaign whereby we're going from the one JUG to the next, is we want to really promote the OpenJDK, which is what a friend of OpenJDK would do. So it's a logical campaign for us to be running. Now, where you can see this, the important part is this badge here. So you can see here one example on Okta on GitHub, that among many different badges that they show, they're also showing this works with OpenJDK badge. So the idea is, and you can see this on the page, use the works with OpenJDK badge to indicate that your project, library, application, or service is known to work with OpenJDK, or uses OpenJDK, or is tested on OpenJDK, or is generally happy with or likes OpenJDK. So that's as broad as it could possibly be, meaning you could have it in your LinkedIn profile. So here's Mike's LinkedIn profile showing the works with OpenJDK badge together with JUG, together with Foojay. And so on your GitHub repository, on your LinkedIn profile, on your website, anywhere where you are using any distribution of OpenJDK, you can just go to Foojay on GitHub. So github.com/Foojay.io/badges. There you will find beautifully created by Gerrit Grunwald the LinkedIn profile banner that you can stick right into your LinkedIn profile, and a number of different badges of different sizes. And you can get creative. So for example, look at what Heinz has done. So he's combined works with OpenJDK with his banners. So you see in his Java Specialist newsletter, this combined. And let's take a look at Julian at Agile. So he's combined this badge together with the Agile badge. So stick it anywhere you like. Let's get the word out there that OpenJDK is great, and that there are many different distributions, and that they're all united around the common OpenJDK. And that's the idea behind this campaign. Foojay.io is on Twitter, inevitably. And there's also a Slack channel with lots of discussion going on every day. So really bringing together the community around a common platform, around a common campaign, around the OpenJDK. That is Foojay. So with that brief introduction, I've really brought all the key points of Foojay together, and please join in if you're listening. We'd love to have you.
Mike, you're on mute.
There we go. Okay. Thank you, Geertjan. Appreciate that. Just wanted to mention too, I noticed that Eric Koslow, who is one of the other InfoQ Java editors, presented on this tour more recently. So,
and also an important point is Eric Koslow has started a podcast. One thing I should have mentioned. So there's the Foojay podcast, and there have been several episodes already. The second one of which was about Java Embedded, featuring James Gosling. So if you want to hear a podcast where James talks at some length about why Java Embedded has always been relevant, continues to be relevant, go to the Foojay podcast. Another one coming up quite soon about the different OpenJDK distributions. So really quite a good thing to keep track of.
Yep. Yeah, I always check it every week to see what's new and going on. So it's a great resource, and the companies that are all part of this is really really good. So okay, so oops, let's see. Oops, there we go. Okay, so at this point, I'd like to introduce Simon Ritter. Simon is the deputy CTO over at Azul. He joined Sun Microsystems in 1996, and he was part of JDK 1.0. He moved over to Oracle, after the merger, and then now he's at Azul, and he continues to help people understand Java as Azul's JVM technologies and products. Simon has been awarded the Java Rockstar twice at Java 1, which is now Code 1, and is also a Java champion. And Simon represents Azul on the Java Community Process, or JCP Executive Committee, and on the expert group of JSR 379. That was for Java SE9. So quite an impressive background. So very happy to have him here with us. So with that, Simon, thank you again for being here with us, and at such a late hour over where you are.
Okay, great. Thank you very much. Yes. So I must admit that I am no longer on the JCP Executive Committee because Azul lost their seat on the Executive Committee when they decided to reduce the number of seats available. We're trying to get back on again. And also I've done the Java SE expert group now since JDK 9. So I'm currently on the JDK 18 expert group, which just seems crazy to me. Right. So okay, so hopefully you can see my slides. Can somebody just confirm you can see my slides?
Yes.
Excellent. Great. Right. So what I'm going to talk about is the question here. Are all OpenJDK builds created equal? And I've got to say that, as I was introduced, I've been doing Java now for, 26 years, since the beginning of Java when I joined Sun back in the days of JDK 1.0. And if you look at what has changed over those 26 years, one of the things that's really significant that has changed is the choice that you have in terms of the build of the JDK that you can use to run your applications. Back in JDK 1.0, it was Sun Microsystems. That was it. That's all you had. Then IBM created J9, so you had a bit of a choice there. So you had J9 or the Sun Microsystems version. But what we've seen more recently, and I'll kind of get into the reasons behind this, is a real proliferation in terms of the distributions. And when Geertjan was talking about the Foojay.io website, he showed you a list of all the distributions that you've got, and you can look at the details of that. And we kind of dig into some of the details about that as we go through. But it is really interesting to see that there's a much wider choice now for which distribution you use. And the question then is, how do you choose one to use? And that's what I'm going to talk about here. So first thing I'm going to do is start with a little bit of a trip down memory lane, because we need to go back in time a bit and think about how we got to where we are now, because there's several things that happened which are quite significant and why we ended up with this big choice. And we can go all the way back to 1999, which is kind of crazy to think that we actually have to go back to the last century in terms of Java to understand where we're coming from. And back in 1999, Sun Microsystems was still the owner of Java. It was still an independent company. And they were being pushed by users of Java to make it part of a standard. And if you look at languages like C or C++, they had standards from ANSI, from ECMA, various other bodies like that. And people were kind of pushing Sun and saying, you really should make Java part of an open standard so people can see what's going on and they know what's involved in Java. Sun was very protective of Java and they didn't really want to do that. So instead of handing it over to an independent standards body, they said, we'll create our own independent standards body. Well, sort of independent. It'll somewhat have control from Sun Microsystems. And that's how the Java community process came about. And so, that's 22 years ago. And the idea behind the Java community process was to allow the development of standards for all different aspects of Java. It wasn't just Java language, wasn't even just Java the platform. It was originally around all different technologies that were related to Java. And that means it was, the Java Micro Edition for embedded systems, for mobile phones as they were. It was the Java Enterprise Edition, so the ability to, have the servlets and EJBs and all those things. We're all going to be specified through this. And that's what's happened over time. So we've had lots of different standardization for different parts of Java using this. And part of this is understanding the process that's involved here. And what this is called, or what I've called this, is the JCP Golden Triangle. And if you look at each specification for a part of the technologies that are used by Java, there are three parts to it. The first part is the specification itself, a JSR, a Java Specification Request. And each JSR has an expert group formed, which is a number of people who are interested in helping to develop that standard. As I said, I'm actually on the expert group for the Java SE JSRs since JDK 9. And honestly, we don't actually do that much now. I'll kind of come back to that a little bit later on as to how that's changed. But it is still very important that we have a formal specification of what Java is. And if you look at the Java SE, you've got the Java virtual machine specification, you've got the Java language specification, and you've got a set of definitions of the class libraries that make up the Java platform. So that's the first part, is the Java specification itself. What is actually included in this? The second thing that you get is a technology compatibility kit, the TCK. And I'm sure lots of people have heard this mentioned in terms of OpenJDK and Java. Now, TCK is actually a generic term because all JSRs are supposed to create a TCK, and the TCK is specific to whichever technology is being developed. In the case of OpenJDK and Java SE, really what we're talking about is the JCK, Java Compatibility Kit, but everybody talks about TCK, so we'll just refer to it in that way. The third part is a reference implementation. So being able to build what's included in the specification. And so these three things all work together, enabling you to understand how they fit together. And what you can say is that you've got the specification, and then by using the reference implementation is where proving that you can actually build the specification. I mean, you could actually write a specification that you couldn't implement. It would be impossible to implement. So it's important to show that the specification that's being created can be implemented through source code and provide that reference implementation. The second thing that we've got is the TCK and its relationship to the specification. And here what we're doing is we're saying, well, okay, let's look at the specification, but let's make sure that that specification is unambiguous. There's not sort of gray areas. And by creating a set of tests, we can verify that the specification is complete and also that it doesn't have ambiguities that might be difficult to determine how things actually work. And then the relationship between the TCK and the reference implementation is, does the reference implementation conform to the specification? So we need to verify that what we've got in terms of the thing that we built from the specification actually matches the specification. So we've got the TCK that verifies that the reference implementation is actually part of the specification. Good. So all these three things fit together, and that's the way that the JCP and the specifications work. Now, moving forward a little bit in history to 2005, it's worth mentioning Apache Harmony. And the reason for mentioning Apache Harmony is that this was something that was started because people not only wanted an open standard for Java, they also wanted an open source version of Java. And Sun had resisted the calls to make Java open source. You know, they thought they'd invested a lot of money in this and they wanted to keep it as a proprietary technology. They wanted to exploit it with ultimately the idea of making money from it. As we saw, that didn't really kind of work out too well for them. You know, I worked for Sun for 14 years and I saw the sort of gradual decline. But they thought that, you know, it was worth keeping it closed source in order to try and monetize it. Now, the Apache Harmony project was started to create an open source implementation, and a lot of work was done on that. They used things like the GNU class libraries, and they started work on their own VM. What Sun then did was to decide that, okay, if we're going to have an open source version of Java, then really they wanted the Sun version of that to be the canonical source. So they wanted that to be the reference implementation for Java. And in 2006, at the Java 1 conference, they stood up and they made an announcement, which was that they were going to open source the Sun implementation of the Java development kit. And that's quite sort of a precise definition of what they did. I was actually involved in this, and I remember people telling me, you have to refer to it this way. It's the open source of the Sun implementation of the Java development kit. And initially what they did was to release quite a lot of source code, but it wasn't the whole JDK. The initial release in 2006, just after the Java 1 conference, was the Java compiler and the hotspot virtual machine. So all of the VM code was there. It took them a while to go through all the necessary due diligence to figure out that they had the rights to release the source code for various different bits, because obviously they had taken contributions from other people in terms of working with partners and so on, and using different source code from different places. And they had to make sure that if they were going to make it open source, they actually had the rights to the intellectual property. And so in 2007, we got to the point where they released almost all the remaining code. Basically, you know, a lot of the tooling that was included in the JDK, the class libraries were all open sourced. The only things that weren't were, there were a few little bits that were still closed source. It was things that Sun didn't have the rights to open source straight away, and they didn't have an easy open source replacement for that. It was things like color management and some of the font rendering and things like that, which were still closed source. It took until 2009 and build 53 of OpenJDK 7 before we had 100% open source that we could build the entire JDK from and have our JDK made purely open source. No binary plugs that needed to be included in that. What's interesting as well, as a little sort of aside here, is that if you look at OpenJDK, you'll find that there is an OpenJDK 6 project. Interesting. So they actually open sourced JDK 7 initially, but there is an OpenJDK 6 project. And the decision was made when OpenJDK was created that they did want to make 6 available, but they had done 7 already, and they were still going through the development of 6 in terms of updates. So what they did was they actually took OpenJDK 7, build 20, and then they retrofitted it to make it into a JDK 6 build. They literally removed bits of code, additional class libraries. They had to modify some of the way that the JVM worked, things like that. And they adapted the JDK 7 build until it passed to JDK 6 TCK, which is slightly weird, but just an interesting aside. So what we've had is 15 years of open source Java. And what we can see here, I think I've tried to hit all the main contributors. I may have missed some, and I apologize in advance if there's some company there that you think should be represented and I haven't put the logo on there. But we've had lots of companies that have contributed to the OpenJDK over the last 15 years. Obviously, Oracle is one of the big ones. I probably should have put Sun Microsystems there, but Sun got absorbed into Oracle. Red Hat have been a very large contributor. Apple, interestingly, contributed a huge amount of code because they decided that they didn't want to actually support Java on the Mac platform themselves. And in order to enable people to still use Java on that platform, they decided just to contribute all the code that was required for like the rendering and the graphics and things like that to the OpenJDK project so that people could build their own distributions. And that's worked very nicely. Other people that are worthy of mention, IBM, of course, Google, interestingly, especially when you think about the lawsuit that happened between Google and Oracle, Google have been a very big contributor in terms of source code to OpenJDK. Amazon through the Corretto build and through what they've done with AWS. Similarly, Alibaba with the cloud that they have. Intel, AMD, both of the sort of chip manufacturers, they've contributed code because at the low level, getting the JVM to work on their architectures. JetBrains with the IDE, they've contributed code as well. And then you've got other people like Bellsoft and so on. One interesting one here, of course, at the bottom there is Microsoft. Again, if we think back in terms of the history of Java, I remember the days when, Sun sued Microsoft because they had done things in terms of changing the way that the JDK worked and including extra libraries in the standard class libraries and removing ones so it wasn't compatible. And so there was a lot of back and forth, and eventually it was settled for quite a large sum of money. But it's very interesting to see that Microsoft have kind of come full circle, and they now have their own distribution of the JDK and they have their own Java engineering team. So yes, we've had 15 years of open source Java. Now, the next thing to mention is the idea of making the OpenJDK more agile. And this kind of goes back to the whole idea of having the standardization through the JCP and the JSRs. Now, that worked very well in terms of having more input and more involvement from other parties that were interested in Java. And if you look back at the JSRs for earlier versions of Java, there were a large number of companies involved in those. You could have like 10 or 15 companies involved in the creation of that specification. But what certainly Oracle thought when they took over was that it wasn't open enough. We had the OpenJDK, but then we had this sort of much more closed proprietary way of standardizing Java. And they wanted to kind of make that more open and get more involvement from not just big organizations, but individuals and smaller organizations as well. To do that, they decided to do it through the OpenJDK itself. And they came up with the idea of JDK enhancement proposals, or JEPs. These were introduced back in JDK 8. So it was after Sun had been acquired by Oracle. And the idea behind this was to allow people to contribute ideas for smaller pieces of work. In the past, big chunks of work would be specified through JSRs, like modularity, for example, in JDK 9 actually had its own specific JSR, and you can go back and look at older versions of Java, and they had other component JSRs as well. But the idea behind JEPs was to specify smaller pieces of work that would make up changes to the Java platform. And it wasn't also about just affecting the Java language or the JVM, anything that was in the JDK. So for example, the compiler might not be covered by the Java SE specification and a JSR, but it is part of the OpenJDK. So this was all about making sure that people could contribute ideas. And the basis behind this is that anybody who has contributor rights in terms of the OpenJDK project can submit a JEP and say, I've got this idea, I think we should include it in Java. People can look at it, they can say yes or no, and then it can go through a process, and ultimately, ideally, it can be included if people think it's good. It's the idea behind this is to give a roadmap for Java, and sort of beyond the idea of just the next version, it's the idea of having a sort of 3-year, at least, idea of what things might be coming in the platform. And if you look at the JEP 0 on the website, you'll find there's a whole list of these things, and many that have been included in previous versions of Java, but also many that have been submitted and haven't yet made it into the idea of being part of the platform. There is quite an involved process that goes on in terms of JEPs, and so this is a diagram from the JEP 0, I think it is, JEP 1 actually is the process. And you can see that you can go through various stages in terms of a JEP. So you start off with a draft, then you submit it, it goes through a candidate process, then it's proposed to target a particular release, then it's targeted, then it's integrated, then it's completed, and then it's closed and delivered. And there's a lot of flow, as you can see with the arrows back and forth, involving the project leads and the various owners and so on. So there's a very formal process in terms of how JEPs must be handled. But essentially, you come up with an idea, you write it into a JEP, you propose it as a draft, and then it works its way through this. Certainly the idea behind JEPs, if you're outside of Oracle, is to come up with an idea, but also have an idea which is more fully formed. And what I mean by that is that you should really have a sort of proof of concept implementation of your idea. It shouldn't be just like, well, I think we should add, some feature to the Java language because I think that's really cool, but I don't know how you do it. What you want is to propose a feature and also have your own sort of experimental implementation that people would look at and say, yeah, actually that kind of works, and so we can do that. So this is the process involved. Now, one of the other things that's been really good about the switch that we've seen to a faster release cadence for the JDK, and we'll kind of talk about that in a moment, is that we now have the ability to include what are called incubator modules. Incubator modules are defined through a JEP, so JEP 11. And the idea of this is to allow for non-final APIs and non-final tools. Well, what does that mean? Well, it's the idea that what we can do is we can introduce new things into the JDK, but without sort of making them part of the standard, without baking them into it, and allowing people to try them out, figure out whether they like them, figure out whether there's some changes that might need to be made, and give time for feedback so that those changes can be made before they're final and part of the standard, part of the full JDK. And certainly this has seemed to work quite well. It allows for feedback. It allows for potentially the removal of a feature if people really don't like it. I think that's probably quite unlikely. And as an example, in JDK 9, we introduced the HTTP2 support as an API incubator module that became final in JDK 11. Based on feedback, I don't think they actually made any changes to that. It all seemed to work very well. One thing that's key about this is that incubator modules are not like beta testing. It's not about taking a sort of half-created, half-formed feature, putting it out there, developing it, and getting feedback as it works, and debugging it. It's about taking a fully formed feature, putting it into the platform, letting people try it, and then providing input about whether they like it in that form and whether maybe some changes are made. So it's not about beta testing. We also have the idea of preview features, and we've seen this a lot recently. Basically, any language feature that's been added in the last sort of 3-4 years is a preview feature. Again, it's defined by a particular JEP, JEP 12. And what we see here is the idea of things that affect the Java language, the JVM, or the Java SE APIs. Incubator Modules is about the APIs for the libraries. It's about possibly tooling, things like that. But in the case of preview features, it's much more focused on the language, possibly the JVM, and in some cases, the Java SE library calls. Once again, it's about fully formed features, provide feedback, maybe some changes. Now, because we have a standard for Java, we need to be very careful about not breaking either backwards compatibility or the write once run anywhere idea. And to do that, what we did was to say, okay, we need to enable those preview features explicitly. And we do that both at compile time and at runtime. At compile time, use the enable preview flag, and we have to specify which version we want to enable those features for. So minus release 14. At runtime, we still have to enable the preview features if we want them to be used, but we don't have to specify which release because that's actually included in the information in the class files that we're going to run. Preview APIs, as I said, although that might appear to be very similar to Incubator Modules, this is only when it affects the Java SE standard APIs, so not things that are JDK specific, things that are part of the core Java SE namespace. So either Java or Java X packages. Okay, so let's look at what's happened more recently with OpenJDK today. And back in JDK 9, when JDK 9 was released, Oracle decided to make some quite substantial changes to the way that Java was going to be developed, the way that it was going to be delivered, and also the way that it was going to be updated. So what they said was that JDK 9 was the last major release of Java, meaning it was the last release that had multiple years of development work that went into it. What they then did was say that they were going to move away from the old release cadence, which ideally was once every 2 years, but they never actually managed to hit that. It was sort of 2 and a bit years, 3 years. Even in the case of JDK 7, it was over 4 years between JDK 6 and JDK 7. So rather than having multiple years between releases, they decided to move to a time-based release schedule. They said, we're going to have 2 versions of Java every year. Every 6 months, March and September, regular as clockwork, we will have a new release of Java. And that makes a lot of sense. What we've seen is that works really well because we've had 9 releases in 4 years. Now, it's just incredible to think that. But, you know, JDK 9 came out in September of 2017. We're now September of 2021. We just had last week JDK 17. So 9 releases in 4 years. Now, what that has done is it's affected the way that new features get added to the platform. In the past, the features drove the release, meaning that when they started planning for, let's say, JDK 8, they decided that they wanted to include lambdas, they wanted to include streams. And only when those features were ready would they actually release JDK 8. If those features weren't ready when they had planned to release JDK 8, they would delay it. And that was seen very much in the case of JDK 9 with modularity, that the development of it took longer than expected. There were some features and realities that people needed to address that meant that they delayed the release of JDK 9 twice. With a 6-month release cycle, that's not practical. You don't want to delay that at all because it'll start running into the next release and so on. So now the idea is that because there are only 6 months between releases, you add the features that are ready when you want to make your release. If a feature is not ready, you just say, okay, delay that feature, not the release. Because it's only 6 months, the next one, it's like, okay, well, we'll finish it off in a couple of months' time. It can go into the next release in 6 months. So that's really fine. The other thing, of course, is that that has made the idea of the preview features and the incubator modules a practicality. It's practical to do that. In the past, if we had years between releases, you know, introducing a preview feature and then having to wait 3 years until the next release before we could decide, well, is it good enough or not good enough, making some changes, doesn't really work. If it's only 6 months, sure, we can make some changes and then maybe another 6 months, and then make it a final feature. So that all works really well. So that's the way that OpenJDK is developing at the moment. It's very important to understand what OpenJDK is, because people often get a little bit confused about this. And OpenJDK is source code. It is the source code to the reference implementation of the Java SE standard. And very importantly, if you want to run Java applications on the Java platform, what you need is a binary distribution of that. And the analogy that I use when I talk to people about this is that you can think of Linux. Linux is an open source project. There is a Linux repository that has the code for the kernel. If you want to run your application on top of Linux, you don't download the source code and then run it on top of there. You need to build it. Now, you could do that yourself, but most of the time what you do is you rely on somebody else to provide the binary distribution of that. So whether it's Ubuntu, whether it's Red Hat, SUSE, or whoever. So it's the same thing with OpenJDK. And this kind of comes back to what I was saying earlier about how we've had this proliferation of distributions. More people have stepped up and decided that they want to provide those. Now, how do OpenJDK distributions get created? Well, obviously, we start with the OpenJDK source. And how that is organized is under a series of projects. Each version of Java has its own project within the OpenJDK. And then there's also an update project as well. And in terms of how it gets developed, clearly Oracle, as the stewards of Java, the people who own the copyright and own the trademark for Java, will be the ones who are making the major contributions in terms of new code, in terms of development of features and so on. But of course, it's an open source project, so we have lots of other contributors as well. People from Azure contribute, people from SAP, people from Red Hat, and so on, all contributing to this open source project. When it comes to actually creating the distributions, what happens is that Oracle, who have been took over from Sun, the main distribution of the JDK. What they do is they take the source code and they build that and they create the Oracle JDK. I haven't put an arrow directly from the OpenJDK source code, and that's deliberate because Oracle use a different license in terms of how they make that available. OpenJDK source code is provided under the GPL license, GPL v2, with the class path exception. Class path exception is there specifically to protect application code from the copyleft or the viral nature of the GPL license. Because if you were to ship your application with a JDK and we didn't have the class path exception, then potentially somebody could come along and say, oh, well, JDK uses GPL. That means anything that builds on top of it is then also required to publish under the GPL. So I want the source code to your application. By using the class path exception, we say that anything that's on the class path or module path is exempt from that copyleft nature of the GPL, and so you don't have to provide the source code to your application. So Oracle uses a different license. They build the Oracle JDK and off they go. Other people build directly from OpenJDK source. So in the case of Azure, we build our distribution called Zulu. We will take the source code, we will maybe make some changes to it, we will then build it and provide Zulu as a distribution. That is licensed in the same way as the OpenJDK source code, GPL v2 with class path exception. Other people will provide binary distributions, and they'll use a similar process that we do, in the sense that they take what's in the repository, they may decide to make some changes, they then build that and provide that as their distribution. Other people may take a slightly different approach, which is that they don't make any changes. They just take whatever's in the repo at that time, they run the build scripts, they create the binary distribution with installer packages, and that's what they give to people who want to use their distribution. So a number of different ways of approaching this, but essentially it all comes from the same source code, all starting from OpenJDK, and depending on what the license is, depending on how the people want to create their distributions, but ultimately it's all coming from OpenJDK. Now, next thing to understand about is long-term support. And what Oracle said when they decided to make the changes from the point of view of a 6-month release cycle was that they couldn't, it wouldn't be practical to provide extended updates for all releases. If you look back to how things used to work, what would happen is that the current release, you'd have updates provided on a regular basis. And they would also provide updates to the previous release with quite a hefty overlap, so that it gave people time to move from, say, JDK 6 to JDK 7 or JDK 7 to JDK 8. With a 6-month release cycle, wasn't practical to say, okay, we're going to support all those releases and have extended updates. To get around that, what Oracle said at that time was that they would use a long-term support, or LTS strategy. And that meant that only certain versions would have extended updates provided to them from Oracle. And what they proposed was 3 years between long-term support releases. Now, I've crossed that out in my slide, and I've said now it's 2 years. And that was a change that was announced last week with the release of JDK 17. What Oracle said was that they want to move from having 3 years between LTS releases to 2 years between LTS releases. They thought 3 years was a bit long. They're going to shrink it down to 2 years. Reaction from all the providers has been very positive to that. So I think that there's no doubt that we will move to JDK 21. Yep, 21. Yeah, that's right. 21 will be the next LTS release rather than JDK 23, which would have been before. Important to understand that LTS releases is not an aspect of OpenJDK. It is an aspect of the distributions that people create of the JDK. Oracle obviously is a distribution, and they have said they want to make LTS releases, and they will decide in the same way that Azure decides, in the same way that Amazon decides, and so on, how long they want to provide those updates for. So that is part of being LTS, is the understanding that it's the distribution that's the important thing. From an OpenJDK project perspective, people can make changes to that for as long as they like. So long as somebody's leading that project, then you can upstream changes to that project, and it can go on as long as people are happy to contribute changes to it. It isn't based on how long Azure is going to provide updates or how long Oracle are going to provide updates or whatever. So as long as somebody's leading the project, things can get upstream to it. So when Oracle made this announcement, they said that JDK 8 would be the first long-term support release. And that was because at that time, it was a release of JDK 9. Pretty much everybody was using JDK 8. Still, many people are using JDK 8. So it was defined as a long-term support release, and that made a lot of sense. What they then said was the next long-term support release was going to be JDK 11. I'm sure everybody knows that already. And as we've seen last week, we had JDK 17 as being the new long-term support release. What that also means is all the other releases between those, JDK 9, 10, 12, 13, 14, 15, 16, are not LTS releases. They're what are called feature releases. They receive updates only for 6 months until the next release comes out, and then they're basically abandoned as updates, and the Oracle move on to the next one. Let's talk about updates, because updates is what most people are really concerned about when it comes to maintaining the stability and the security of their applications. They want to make sure that if they decided to use JDK 8 or JDK 11, how long are they going to be able to get those updates for? And the way that updates to Java are organized is that there are 4 scheduled regular updates each year. Those come out in January, April, July, and October. I'm sure everybody who's using Java is familiar with that, but there are 4 every year. And these are sort of slightly offset from the release of the new versions. New versions in March and September. The updates are in those 4 months. What that does mean is that sometimes we get, well, a little bit of a situation where, okay, this month we've had JDK 17, and then next month we'll immediately get an update to JDK 17. So only 1 month later, we'll get 17.01 will come out as an update to that. And then in January next year, we'll get the update 17.02, and then obviously subsequent ones after that. Now, the way that this works in terms of the OpenJDK is that the changes required for any bug fixes or security patches or whatever are only upstreamed by Oracle into the current release of the Java version. So right now, any changes that are being made are only being upstreamed into the JDK 17 project in OpenJDK. If people want to make use of those in older versions, then in terms of the OpenJDK projects, somebody has to take those source code changes and backport them to whichever versions they want to continue to support, whether that's JDK 11, JDK 8, or 7, or 6 even. That comes with a set of challenges because clearly, you have to look very carefully at what's happening in terms of JDK 17, and if you're moving back to JDK 8, how do you migrate a patch that affects a particular part of the system to JDK 8, because things will have changed between 8 and 17. Also, there are challenges in terms of features being removed. JDK 11 is a good example. A number of different things were removed, and for example, some of the libraries for Corba is a good example. Corba got removed. If there's a security fix or a bug fix that will be required for Corba, it's not going to be in JDK 17 because there is no Corba. So you need to think a little bit carefully about that because there's nothing to backport for those. Talk a little bit about the availability of updates specifically from Oracle, because we've seen a lot of changes in terms of licensing, and that has been one of the things that's led to this proliferation of the number of JDK distributions that people have created. So Oracle said that they would have specific LTS versions of the Oracle JDK, JDK 8, 11, 17, and next one's going to be 21. Everybody else who decided to also create JDK distributions has decided to do the same thing. It's very logical because, if you're going to have LTS releases, you might as well follow the same thing so that your users are not confused about, okay, Oracle are providing 11 as a long-term support release. Azure have decided that 12 is a long-term support release. Amazon have decided that 13 is a long-term support release. Doesn't really make any sense. So everybody's aligned on the same set of LTS releases. Now, when Oracle released JDK 11, the Oracle JDK 11, they decided to change the license that they used for that. Prior to that, so good old JDK 8 and JDK 7 and JDK 6 used a thing called the Oracle Binary Code License, BCL. And what that said was that you could use the JDK for free in pretty much any situation. If you're running it on your laptop, if you're running it on your desktop, if you're running it in your server, then it didn't really matter what you were doing with it. You could run it without having to pay a license fee or a support fee. The only restriction was what was called the field of use restriction, and that said that if you were using it in an embedded device like a in-car infotainment system, or if you were using it to provide Java on a mobile phone or a kiosk or something like that, then you would need a separate license from Oracle to do that. That sort of goes back to the days of when Sun was still making some money out of Java, specifically on the mobile phone side of things. So that's the Oracle Binary Code License, very free usage. And that's what people got used to. They got used to the idea that if they wanted to use Java, they'd go to sun.com, they'd go to oracle.com, download the version they wanted, and get the updates from there without having to pay for them. All free, all good. JDK 11, Oracle JDK 11, they changed to a different license, which is called the Oracle Technology Network License Agreement. Obviously, they've got the lawyers involved in terms of naming it. And what that says is that there are much more restricted places where you can use Oracle JDK for free. In fact, there are only 4 places that you can do that. First is personal use, which means that you're at home playing Minecraft or something like that. Second is you can use it for development, your IDE. If you want to do demos, if you want to do testing, then that's all perfectly acceptable. And then for production use, as we would kind of think about it in a commercial environment, only 2 situations where it can be freely used. And that's if you're using Oracle approved products, which is things like Oracle middleware or Oracle applications, or if you're running it on the Oracle cloud. Anything other than that, you would require a Java SE subscription. So you'd have to buy that from Oracle. And that was a big change because it suddenly meant that people who were expecting to get Java for free from the Oracle website now had to think very carefully about whether they were going to download that because it would require them to buy a Java SE subscription. And as I say, that's what sort of led to a lot more distributions of Java than we've seen in the past. JDK 8 is a little bit of hybrid in terms of the license from an Oracle perspective. So up until update 202, which was March 2019, April 2019, no, January 2019. Yeah, January 2019 was update 202. That used the binary code license, meaning that you could quite happily install those on your machine, use them for free, not a problem. As of JDK 8 update 211, which was April 2019, that switched to the Oracle Technology Network License Agreement. So if you are at home playing Minecraft, you will still see messages pop up on your desktop saying there's a new version of Java, you can install an update, and that will work quite happily. But if you're a commercial user and you go and you try and download that from Oracle, there's a big kind of box that says, you know, you need to be careful, you need to be aware that there's a change in license. If you're updating JDK 8 with these later versions, updates, then that might incur the use of a Java SE subscription to do that. To make things even more interesting, or should I say complicated, last week, Oracle also said that they were going to introduce yet another license. And in this case, for JDK 17 and later, this is now going to use the Oracle no-fee terms and conditions license. And what that says is that they will provide updates that you can use for 3 years under that license. And the 3 years comes from the fact that they're going to do 2 years for the time between long-term support releases plus 1 extra year. So having switched 2 years between LTS plus a year is 3 years. So that means 3 years of updates available under this license. After those 3 years, it's going to revert back to the Oracle Technology Network License Agreement, meaning that you then have to buy a Java SE subscription if you want to go beyond 3 years. You need to be very careful in terms of looking at the wording on that license, because although it says no fee terms and conditions, there are some restrictions in terms of where it can be used freely. So no fee does not always mean free. I actually, when I read the license, there's a certain ambiguity, I would say. Clearly, their lawyers would argue that there's no ambiguity at all. They've made it very clear where that license can be used and where it can't be used. But when I look at it as an end user, I look at the wording such as, you know, maybe used internal applications internally, and I don't quite know, does that mean I can run a web server because it's internal, or, you know, things like that. So be careful, look at the license, talk to your lawyers and understand what exactly that does mean. Now, what do we do about addressing vulnerabilities in Java? Because this is something very important, is that if we're running mission critical applications, if we're running things that have sensitive data in them, we need to make sure they're as secure as possible. And one of the things that Oracle did when they made these changes was they realized that there would be more distributions. They realized that because they were effectively turning off the free access, other people would step in and provide alternative distributions of JDK. Very sensibly, I have to say that Oracle did a great thing here. They said, we need to make sure that those builds are as secure as possible. And to do that, we need to bring in those developers who are involved in this so that they have access to the information about security vulnerabilities and patches that are being developed. To do that, they created the OpenJDK Vulnerability Group. Even though this is part of an open source project, it is a closed group. So people are allowed to join it basically by invitation. All the people you would expect to be there. So there's Oracle, there's Azure, there's Amazon, there's SAP, Red Hat, and so on. And what we do as a group is we work together collaboratively. There's engineers from all these different companies who actually look at the vulnerabilities that are identified and reported for Java, and then we develop fixes for them, and we then upstream those into the OpenJDK repositories after the update is made available. So before that, we keep everything secret. There's no publication of any email. all of our email between the different parties involved is encrypted. And the idea behind that is obviously that we don't want any information leaking out, because until those patches are available, we don't want people to know what the vulnerabilities are. Now, what this does is it gives the people who are involved in the vulnerability group advanced information about those security patches. And that's very important, because what you don't really want is a situation where Oracle publishes an update and in the release notes, it lists all the CVEs, the common vulnerabilities and exposures that are identified and addressed in that particular release. Because at that point, the hackers can look at that and go, "Oh, that's a good one. I like that. I'll try and exploit that. It's a 9.6 or it's 10.0. I'll exploit that." And they go and try and find machines that haven't been patched. And if people have to wait until Oracle release the update with the changes to the source code, then it takes time to do the backporting, it takes time to do the building and the testing, and there's a big delay. By having the people involved in the vulnerability group, it means that they know what's coming. They have time to do the backporting where necessary. They have time to do the building. They have time to do the testing, the TCK, and make sure everything is ready so that when Oracle release their update, they can release their update, fairly quickly after the update comes from Oracle. And that way there's a minimal gap in terms of how long you have to wait. In terms of what Azure does, I work for Azure, so I'll tell you about that. We aim and are very successful in terms of delivering our updates effectively simultaneously with Oracle. And by simultaneously, I mean we've done it within 60 minutes since March 2019, when they stopped providing free updates, JDK 8 and JDK 11 also. So up a maximum of 60 minutes. I think the fastest we managed was 22 minutes. The slowest was 59 minutes, but we've always been within an hour. So no possibility of somebody being able to exploit that. Now, people will say, well, how important is it to have updates for my JDK? Surely Java's 26 years old now. You've found all the security vulnerabilities and you've fixed them all, so it's all good. No. If you look at OpenJDK, there's over 1.5 million lines of code. And the reality is that there will probably always be situations where people can find vulnerabilities that can be exploited in there. It's just not practical to eliminate every single possible vulnerability. And what I did was I went back and I looked at each of the sort of most recent updates over the last few years, and what was the highest score for a vulnerability in each of those releases. As I said, vulnerabilities are defined through CVEs, common vulnerability and exposure, which is a description of what the vulnerability is. And then there's a score associated with that, a common vulnerability scoring system, which ranges from 0 to 10.0. 0 is isn't a vulnerability, and 10.0 is a critical vulnerability. That's the kind of thing where you don't need to actually have physical access to the machine, and my 15-year-old son could be sitting at his computer, write a script, and be able to gain access to your machine. So it's a really, really bad vulnerability. And if we look at the CVSS scores that we've seen here, the first one, after Oracle stopped providing free updates to JDK 8, had a vulnerability of 9.0 in it, a critical vulnerability which really needed to be addressed. So that's the reason why you should be looking at making sure that you deploy updates for security patches as quickly as possible when there is a high scoring vulnerability that's identified. Fortunately, since then, we haven't had any critical vulnerabilities, but we have had a number of high vulnerabilities. The other thing that's worth noting here is that if you dig into a little bit more detail on that April 2019 one, the 9.0 score came from a vulnerability that wasn't even in the JDK code. It was in a Windows DLL that was used to build the JVM. So that's something to consider as well. It's not just the Java code that might have vulnerabilities in it. The other thing I did was just to do a sort of an analysis in terms of how many vulnerabilities have been identified in Java over the years, and I went back about 6 years on this. It really as far back as I could find details for it, and we can see that fortunately, most of the vulnerabilities have been in the medium or low range. We had a few in the high, 56 there, and I broke criticals down into 9 to 9.9, and even the 10.0 as a separate one. Again, 59 in terms of critical vulnerabilities. So a reasonable number. Doesn't mean Java's bad in terms of security. It just means that there are issues that had to be addressed. CPU and PSU. This is one of the things that Oracle does for pretty much all of its software. And so it's one of the things that we at Azure follow in terms of what we do for our updates. So Oracle provides 2 versions of each update. The first of those is called the CPU, or Critical Patch Update. And what that does is it only contains the changes which are related to the security patches. The idea behind that is that if there is a critical vulnerability that needs to be addressed very quickly, because it's only a small set of changes, you can do quick smoke testing, make sure your application actually starts up and does some basic functionality. Then you can deploy that update onto your machines as quickly as possible, make sure you've got maximum stability for your applications. The PSU, patch set update, is the full version of the update. So it includes all those security fixes plus everything else, bug fixes, performance improvements, any other source code changes. And the idea behind that is that if you compare the two, typical CPU will be, maybe a couple, maybe as many as a dozen, 15 changes for security patches. A full PSU could be 300 or 400 changes in terms of those other things. So there's more potential for those changes to affect the stability of your applications. What you can do is you can say, if I need to roll out the security fix very quickly through the CPU, spend more time doing more rigorous testing on my application with PSU, make sure I'm happy with that. When I am, roll that out and make sure I've got my applications as stable as possible. So the CPU is maximum security, PSU is maximum stability. Again, people will ask me, well, how important is it to have both a CPU and a PSU version of the update? And the answer is, well, yes, it actually quite is. Because if we only look at last year and the July update, what we find is that the PSU, update 252, and most of the time PSUs are even numbers, that had a fix in it, which addressed a particular problem that had been identified, and Oracle created a fix. Great, fixed the problem. But unfortunately, that had an impact on some pretty commonly used software, Hadoop Cluster, Solr, and Lucene. Those packages would not start if you installed that update, because the fix that they had for that problem actually broke those pieces of code and they wouldn't start up at all. Now, it took Oracle nearly 2 weeks to fix the fix, which meant that there was 2 weeks when people couldn't deploy that update if they only had access to the PSU. And in fact, it was even longer than that because, of course, Oracle took 2 weeks, nearly 2 weeks to fix it. Then people had to do the builds, they had to do the backporting, they had to do the testing. So it was several weeks between when that was identified as a problem and when people could then use that PSU. If you had had access to the CPU build, update 251, that didn't include the fix which had that problem in it. So you could have said, right, I need to address whatever security vulnerabilities are in there. And the highest one in that case was 8.3, not critical, but quite high, but it could have been critical. And you could have then said, right, we'll roll that out, make sure our systems are secure. We can still run our Hadoop cluster, our Solr instances, and then we'll wait for the fix to the fix. And when we're happy that we can then update our machines, then we'll roll out the version of the PSU. So as I say, it's quite important to have both versions. Choices of OpenJDK distribution. So let's have a look at what's available there. Well, funnily enough, the first one I'm going to start with is one from a company called Azure. Why would I do that, I wonder? Well, yes, because I work for Azure, I will talk a little bit about Azure and Zulu. I won't belabor the point, and I will talk about others, so don't think that I'm just going to use this as a marketing pitch. What we do is what you would expect, which is we take the OpenJDK source code, we do backporting to older versions, and we actually support more versions than anybody else. And that includes Oracle, because we support JDK 6, 7, 8, 11, 13, 15, and 17, which means our engineers are very busy every quarter making an awful lot of builds, because there's, what is there? That's seven different versions that we support. And then we have very wide platform support as well. We support all the standard ones you'd expect, such as 64-bit versions of Windows, Mac, Linux. If you're using things like Windows XP, we can also provide builds for 32-bit Windows and 32-bit Linux. And then we've got Solaris Spark, we've got Solaris Intel, and ARM32, ARM 64-bit, and we've got some other ones as well for more kind of embedded applications like PowerPC, MIPS, and things like that. So as you can see, we generate literally hundreds of builds every quarter if you take the matrix of those versions and those platforms. Very much a drop-in replacement for the Oracle JDK. It is designed that way because it's a build of OpenJDK. It's tested with the TCK, so it is just a drop-in replacement. Don't have to change any code, don't have to recompile anything, just change your path, change your Java home, and off you go. In terms of what we do for extended support, as I say, what we do is we make sure that we backport all bug fixes and security patches from the current OpenJDK release where appropriate to the older versions. Obviously, if there's a new feature in JDK 17, doesn't exist in JDK 7, we won't backport it to that. From the perspective of how long we do that for, we will do 8 years of active support, meaning that we will provide those quarterly updates for 8 years after the release of an LTS. And then we have a further 2 years of passive support, which is where we will not provide those regular quarterly updates. But if you do still find a problem, you can report it to us, we'll figure out what it is, generate a fix, and then do a special update for you. So you've effectively got 10 years that you can use a long-term support release for in production. What we also decided to do, kind of as an experiment really, was to offer medium-term support releases. And again, this comes back to the fact that, OpenJDK doesn't have the concept of extended support. It's only about the providers deciding what to do with that. So we decided to offer medium-term support where we'd said, 3 years between LTSs means it's quite a long time to wait for being able to deploy certain features. We'll offer support updates for 13 and 15, and we'll do that until 18 months after 17 comes out. So people have got 18 months to move from, say, 13 to 17. Really sort of bridge to the next LTS. What we also do is offer the standard support kind of functionality, 24/7/365 issue logging with a 1 hour response time SLA. We'd love to be able to say that we can fix every bug in 1 hour, but I don't think we can do that. So we will respond and say, yes, we've got the report, we will start working on it. And if need be, we can do follow the sun problem resolution, handing over from the team in US to the team in Europe, to the team in Asia, and then back again. Other builds of OpenJDK. So I won't go into quite as much detail about them because I don't work for any of these companies, but I will highlight that there are a plethora of choices. Obviously, the kind of incumbent, if you like, Oracle, and they have 2 different ones. So there's the Oracle JDK, which is under this different licensing, the different sort of commercial, whether it's BCL or Technology Network License Agreement or the no-fee terms and conditions. But they also provide the Oracle OpenJDK JDK, which is under the GPL v2 with class path exception. And that's the one which you'll only get for 6 months. So there's no extended updates on that one. Tamarind is a build from the Eclipse Adoptium project, and this is the kind of successor or replacement for the Adopt OpenJDK project that used to provide builds until July. I'm actually on the Adoptium steering committee because Azul sponsors the Eclipse Adoptium project, so we do help out with that. That's available freely. We can provide support on that. The Eclipse Foundation don't provide support in this kind of commercial way, which is just one thing to bear in mind there. Red Hat Enterprise Linux, if you're using that, you also get updates to the JDK included in your subscription, so you don't have to worry about that if you're running Red Hat. Bellsoft is a Russian company that has a distribution called Liberica. They're very popular in Russia with the Russian government because they're a Russian company. Then we've got Dragonwell from Alibaba, and because they have their Alibaba Cloud, so they've created their own distribution, which you can use on the Alibaba Cloud, but it's also available externally. So if you want to use that, but in the same way that it doesn't come with support. There's no kind of paid for support if you're using it outside of the Alibaba cloud. Same thing with Pareto, that's from Amazon. So it's primarily targeted at the AWS cloud, and you can use it outside of that for free, but there's no support options. There's nobody to call if there's a problem or things like that. Microsoft have their own JDK. Again, this is one of those things that I find a little bit weird, having been through the early years at Sun. And more recently, they've decided to create their own builds. They were using the Zulu builds from Azul. They decided to make the switch, not because they were unhappy with what we were doing. It was more to do with the fact that they wanted to move all of the work in-house, because if you look at what happened with the SolarFlare project, they had some issues, and they thought, well, you just want to make sure that we've got control over the builds and everything like that. So they just did that. SAP have a build called SAP Machine. Once again, it's primarily targeted at the SAP software, but you can use it for free, but it doesn't come with any kind of support. So nobody would report a problem to if there is one. Many Linux distributions come with their own JDK that you can download as part of the repo. Be a little bit careful about that, because we've done some research on that. And as Geertjan, our real CTO, says, that some of those can be what he describes as mystery meat JDKs. You might think it's update 202, but it's actually update 193 because they've labeled it incorrectly. Last one, there is a company called OpenLogic that is an open source support company. They have done one build of OpenJDK. Last time I looked, it was about I think over a year old. So they're not doing kind of regular builds on that, but they do claim to be providing support for that. I'm not quite sure how they do that. To summarize then, basically, I think it's fair to say that Java is maintaining its popularity. The 6-month release cadence is definitely helping with this. The fact that we're seeing more changes coming through in terms of the language, in terms of the JVM, more quickly than we've ever seen in the past, is definitely keeping things fresh and keeping it as an appealing language for new developments. LTS releases are definitely key to most enterprise deployments. If you're a startup company, if you're using microservices with CI/CD, yeah, you might be able to use a new version every 6 months, but most people are looking at long-term support for running the same version for several years. That's very important from the point of view of continued security, continued stability, older versions. Now what we're seeing is whether you want to upgrade every 6 months, or if you're using the Oracle, and the LTS, then it's every 2 years now, rather than every 3 years. So basically, to answer the question, which I started with as the title of this slide, are all JDK distributions created equal? Well, I think what you need to do is you need to, when you're making a choice of JDK, you need to ask several questions, and you need to think about what are the qualities that I'm looking for in a JDK distribution or OpenJDK distribution. First of those, is it TCK-tested? Has somebody run all the tests to make sure it passes that, and therefore it's compliant with the Java SE specification? Are all the bug fixes and security patches that are contributed to the current release being backported to older versions, or are there some that are missing? So is everything that you want in that backport? How quickly do you get access to the updates? Oracle released theirs, and then how long do you have to wait before you get yours? Meaning that there could be a period of time when you're exposed to vulnerabilities because people know what those things are that are fixed and then can try and exploit them. Do you get both the CPU and the PSU? Is that important in terms of being able to address security vulnerabilities very quickly, using the minimal set of changes, and then waiting until you've tested more carefully with PSU before you deploy that? And then the last question, of course, who are you going to call? In this case, when something goes wrong. If you do have a problem and you need help with it, where do you go for the more traditional kind of support rather than maintenance? And so that's what I'm going to leave you with. So with that, I'll end the presentation, and then we'll see if anybody has any questions. There we go.
Yeah. Awesome, Simon. Thank you very much for that great presentation, and especially the historical perspective on things, and especially like when the JEPs started, relative to the JSRs and all that. I think that was awesome, and it makes it much more clear in my mind, especially as I write about Java on InfoQ, and to know some of these things a little bit better, I think, would provide better information for our readers. So we do have a few questions.
Sure.
I have to pop over onto my browser. Let's see, over here. The first one is, how are custom JVMs licensed?
Well, it actually depends on the provider of the custom JVM. So, for example, if we take Azul as a good example, we have a custom JVM called Prime, used to be called Zing. And what we do there is we take OpenJDK as the starting point, and then we make modifications to that in terms of some of the internal functionality, replacing all the garbage collectors with one that's called C4, replacing part of the JIT compilation system with something we call Falcon, adding some warm-up elimination technology called Ready Now. But then we pass all the TCK tests on that, so we make sure that it's still fully compatible with other JDKs and JVMs. But then we license that separately. So we license it under the way that we do. So we charge a license fee per use of that JDK or JVM within a commercial environment. But it would be down to the provider of a custom JVM as to how they want to do that. They're not required to use the GPL v2 if they don't want to. So there's no requirement on that.
Okay, we have a few other questions, but just wanted to remind folks out there, there was a Google Docs shared to enter your name and email for the IntelliJ license giveaway, which we'll do in a little bit. So if you can go ahead and do that while we're finishing up. Let's see, so, let's see if I can get to the, okay, here we go. Could you provide us some recommendations to choose a JDK for development and for production?
Let me think about that for a moment. Well, yes, I mean, certainly I'm, as an employee of Azul, I would recommend that, Zulu is certainly a good build to use. We as a company have a lot of experience. We have very talented engineers, many of whom used to work for Sun, many of whom used to work for Oracle. And we do make our Zulu builds free through the community edition. So you can go to our website, you can download those for free, and you can use those for development, for testing, even in production if you want to. There are alternatives, like I say, Temurin from the Adoptium project is another free version that you could use. Now they are TCK tested. There were some issues with Adopt OpenJDK where they lost their TCK license. Now they've moved to Eclipse, that is TCK tested again. Same thing with Corretto. I mean, that's TCK tested. It really comes down to a sort of personal choice of where you think you're going to get the most reliable, if you like, help and most reliable sort of distribution from. But like I say, I like Zulu. I work for Azul, so I'm going to say that.
Yeah, and then you may have answered some of that too in your last slide in the summary of, what to ask yourself when choosing
Exactly. Yeah.
an open, downstream distribution of OpenJDK. See, the next question is, why would a company release its own build without making any modifications to the source code? And would it all be, well, there's a second part to that.
Mm-hmm.
So would it all be licensed? Would it all be the licensing and support from different sources or differences, support differences, sorry.
Yeah, so the reason I put that particular thing in my slides is because if you look at companies like Azul, we do backporting independently. So we will take the changes from JDK 17, move them back to JDK 7 or JDK 6. In the case of Amazon, they do the same thing with their Corretto builds. They'll take the changes, they'll do independent backporting. With certain providers, and let's take the Adoptium project, they do not do any backporting work at all. They don't have the resources to do that. So what they are actually providing is simply a build of whatever is in the repository. What they rely on is other people doing the backporting and then upstreaming those changes into, let's say, JDK 8 repository or JDK 7 repository, well, JDK 8, and then they will take, once those changes have been upstreamed, then they will build those and have a build which has the update in it. But they have to wait for somebody else to upstream those changes first. So that's really the kind of significant difference there, is that some companies will do the backporting independently like us. Other providers will have to wait until the change has been upstreamed into the relevant update project. From a licensing perspective, it doesn't make any difference. It's just GPL v2 with class path exception for the OpenJDK source code.
Okay. Oops. I did it wrong. Okay. And what has changed in recent Azul announcement with respect to OpenJDK and Zing? Since Mark announced 2-year LTS, is Azul planning to drop MTS? Or maybe that should have been LTS.
Right.
I don't know what MTS is.
Yeah. So MTS is our medium-term support.
Oh, okay.
Which is where we were doing 13 and 15. Yeah, we haven't decided yet. We may go down the route of offering one medium-term support release, which would be the sort of the year. So that would be would be 19, wouldn't it? Yes, 18, 19. Yeah, so it would be 19. Whether that proves to have any popularity, I'm kind of doubtful myself. So we may not bother. We might do it for the first update, and then if nobody is interested, then we'll probably abandon it. But at the moment, we're looking at doing one MTS release between the new 2-year LTSs. Okay,
awesome. I think that's it for the questions. That's for anybody who may not be familiar, the Eclipse Tamarin is relatively new from the Adoptium working group, which was the old Adopt OpenJDK. And I have to get used to saying Tamarin instead of Turmeric, because turmeric is the spice and mustard. But
yes.
my Java News Roundup on Monday went out with Turmeric, and thankfully one of the other editors caught it. So,
yes, Tamarin is actually is interesting because Tamarin is an anagram of runtime.
Runtime, yeah.
Yeah, and it's also a chemical compound which is very closely related to caffeine.
Yes, yeah, I thought that was interesting when I first read about that back then. So that was very clever, actually. So. Mm-hmm. But yeah, look for that as well. And Microsoft OpenJD or Microsoft build of OpenJDK is also relatively new, so they're a new player in all that. But I don't see I don't know if Chandra or Barry can see any other questions in the YouTube. If not, we can move on to. To the IntelliJ license giveaway. I have a
yeah, Mike, there are no other questions except there was a request to repost the links to both the raffle and the JCon conference. So if Barry or if Barry could post those links, because none of us can actually share URLs on YouTube.
Yeah, well, I'm trying to repost the link and YouTube isn't accepting it.
Oh, lovely.
Long link. So there may be some other way that we can get it to our.
Okay.
I know we have a handful of folks already submit their name and email address.
So since it's 1 o'clock in the morning my time, I will pass on watching the raffle happen. So
okay,
I'll drop off at this point.
Yes, yes, thank you. I almost forgot. Sorry, I really appreciate you staying up, and Geertjan as well. So
yeah, because it's even later for him.
Yes, it's actually 2 in the morning in my part of the world. So.
Right. Thank you very much.
So, Simon, thank you very much.
Thank you very much. It's been great. We should
have both.
We should do this again soon.
Yes.
Yes. Hopefully in person next time.
Yes, absolutely. So,
okay.
Right,
bye for now.
Bye bye.
All right, folks. I will share my screen and I will go over to here and present again. Okay, so here's where we left off when we started the meeting.
Take a few minutes. The a correct raffle link is earlier on in the chat, and if people can access that, let's give them a few minutes.
Yep, absolutely.
Go up and find that. If not, then if any member of the JUG team has a link that they can send me via the back channel, I'll try to repost that.
Okay, awesome. So yeah, with a couple of things I wanted to mention since we have a few minutes. Some upcoming events. InfoQ Live, they've been doing these roughly once a month, once every other month. during COVID, of course, they couldn't do their normal QCon conferences that they hold around the world. There's one in New York, one in London, and so on. So the next one is coming up on Tuesday, October 19th. There is usually a theme for each one of these. The one they had last week, I believe, was on cloud, but I didn't get a chance to attend that. So, but anyway, you can actually go to this link here to find out what's happening. It's usually like, just the morning time frame, maybe 3 or 4 talks, or maybe into the early afternoon. And I mentioned before, the JCon Online is Tuesday through Friday, October 5th through 8th. EclipseCon is also coming up at the end of next month, on October 25th through 28th. I believe the talks are all wrapped up there. And what I failed to mention on here is the Jakarta One conference. That's on December 7th. And that's, if you've been to some of these, this is a great day of excellent talks. And it's all virtual. And as a matter of fact, the first one of these, the ones that they hold in the US, was in 2019 before COVID. And it was a virtual event that was actually for, I believe, 19 hours, but it's gotten scaled back a little bit to about 12 hours. So, and this was, to accommodate a lot of folks, around the world, and all the recordings are saved, and you can go back and look at them in time. So upcoming meetings is next month, October 12th. The website will be updated by tomorrow morning. It's JSON Web Tokens and what Java developers need to know. And this is Dan Moore from Fusion Auth. So he'll be with us next week. The Eventbrite is already out there. Some of you, or some folks, have already registered, and the website will be updated with that link to register for that. And if you remember, 2 weeks ago, the Quarkus World Tour should have been then, but unfortunately there was an issue with the scheduling, and long story short, they couldn't provide a speaker for 2 weeks ago tonight. And you may remember that Neha Sardana gave a great talk on Spring Security in its place. So we definitely hope that we'll get, we've confirmed a date with them, and we hope to get a speaker and a topic very, very soon. All right, so we have some ground rules for the giveaway. You can read them right there. I'm not going to read them out loud, but one of the, I think, if you want a prize within the last 6 months, then you're not qualified to win another one. So that's the big key takeaway from this. And so how are we doing on the raffle and other things?
Well, I posted the link about 2 or 3 minutes ago successfully. Okay. So I think we're good to go. Okay.
So any other questions or concerns, or, if you have any thoughts on a talk, that we're always listening, we always encourage people to, if you have a burning desire to give a talk on a particular topic, send us an email at info@jsjug.org. And, we're more than happy to, schedule a time. Right now we're booked through November. We're looking to get Billy Carando from Oracle, and also the combination of Matt Rabel and Josh Long. They recently presented on Spring Native, which is relatively new project in Spring. It's basically going to be a, I don't know if you want to say a competitor or an alternative to GraalVM native image. So that's, it'd be great to have those two guys present at the same time for that. So how are we doing on the raffle, Barry?
I think we're good.
We good? We have a winner yet?
Oh, am I picking a winner?
Yeah, I'm sharing my screen, so I can't run any kind of random drawing at the moment.
Give me a minute. I'll do a drum roll while I pick a winner.
Okay, great. What else? Oh, we have, what I mentioned already, we have a meetup page. If anybody came late, and announced that at the beginning. So a lot of good things are coming up. JDK 17 was just released, as you all know. Jakarta EE10 is scheduled to come out in the first quarter of 2022. The big news there is that along with their platform profile and their web profile, they've come up with a core profile that's just for a smaller set of application types. And there were a number of those specifications that were assigned to that. So microprofile 5 is scheduled to come out sometime I think in November. I may have seen some emails that they might be out a little bit sooner than that, but I need to verify that. But you can look for that within the next month or so.
And we have a winner.
All right, cool.
And I'm going to pronounce the name. We have this person's email. It is Chirag Vithalani. Chirag, you are a winner.
If you can verify in the chat that you're here, that was one of the other ground rules, is that you need to be present for this.
I know for a fact that he's here.
Okay. All right. Awesome. Awesome. So you will get an email with a PDF file that is it's a coupon to redeem at jetbrains.com. There is an expiration date on the coupon, but that's the expiration date of the coupon itself. Your license for IntelliJ IDEA, is good for 1 year. Okay. So with that, as I like to end all of my presentation, it is that time of the night, to celebrate, and the end of a long day at work, and thank you all for spending your time, your free time here with us, wherever you are in the world. Thank you for joining us. We really appreciate all of your support. So with that, thank you very much. Unless there's anything else, we will see you next month.